Hey, hello and welcome to today's GFG problem that we hope you're doing well. So let's say today's problem check for BST. Okay, so what the problem is saying is we'll be given a root of the binary tree and we want to check whether it is a valid BST or not. Okay, so first of all, let us see what is the property of BST. For example, there's a given node n, okay, and there is this right subtree, right, on the right side of the node and left subtree on the left side of the node. Okay, so what the BST property says is all the nodes values on the right subtree have greater values than the value in this particular node. Okay. And all the values of the nodes in the left subtree have values lesser than this given node. For example, let's quickly see. So, for example, so here you can see, right? So there's this 8, right? On okay. And all the nodes, right, have greater values than 8, have greater values than 8. And all the nodes on the left side of 8 have lesser value than 8, and this property is followed on each and every node of BST. You can see here, right? On 5 7 is greater and 3 is lesser. On 10 12 is greater and 9 is lesser. Okay, so this is a valid BST. Okay, so I hope you have got the property of BST. Now let's quickly uh, go through the approach. Like, let's quickly have a dry run how to solve this problem. So what we're going to do, so we are going to start with the root, okay, and we are going to pass two variables which will be minus infinity. I'll just represent with minus infinity plus infinity. So two variables like minimum, okay, which minus infinity means that it is going to be integer minimum, whatever is the minimum possible value of integer, and max will be plus infinity, whatever is the integer, which will be integer max value. Okay, which will be integer max value. So we're going to check at each node whether this the node the node should be greater than equal to minimum and less than equal to maximum. Okay, maximum. So yes, so it is definitely following. So when I say, again, when I say minus infinity, it is nothing but int minimum, right? Whatever is the minimum possible value of integer, and plus infinity means int maximum. Okay, so this is following the property. We are going to go to the left. So when we go to the left, okay, we are going to pass the node value itself as a maximum. Why? Because the left subtree should be lesser than equal to the parent node, right? To the parent node. Okay. And that is why we are going to pass 8. Okay. 8. So here, definitely we are going to check here. Is it following the property? Yes, this is greater than this minus infinity and less than equal to this 8. Okay. So we are good here. So we are going to pass uh, 5 now to this particular minus infinity and 5, because 3 should be lesser than equal to 5 and should be greater than equal to minimum. Okay, so yes, it is following the property, and since it does not have any left and right children, we are going to go back. Okay, and when we go to the right, we are going to pass this particular node value as in the as minimum. Okay, and whatever is the maximum, we are going to keep it unchanged. Okay, whatever was flowing, we are going to keep it unchanged. Why we are passing node value as in the minimum? Because this should be this should be greater than equal to this parent node, whatever is the node, right? It should be greater than equal to 5, and then it should be lesser than equal to the the parent node, which is the, I mean, this particular node, right? So here you can see, right, 7 is definitely greater than equal to 5 and less than 8. Okay, okay. So for example, there's this given node, right? So when we go to the left, so we are going to, whatever is the minimum, okay, it will be as is, but the maximum value will be the node value. And when we go on the right side, we are going to pass this node value in the minimum, and maximum will be as is. Okay, whatever is flowing from above. Okay, okay. So I hope you have got this. Now let's quickly dry run. So now, yes, this is following the property of BST. So we are going to go back now. We are going to go back. Okay. Now, when we go to the right side again, so what are we going to pass? 8. Okay, 8 and plus infinity. So this max is going to be unchanged, but minimum we are going to, when we go to the right, right? When we go to the right, this particular case, we are going to pass the node value, which is we are going to pass 8. What it says, that 10 should be greater than equal to 8 and should be less than this plus infinity. I mean, there's no bound to the maximum, right? It can be any value. Okay, now we are going to go to the left again. We are going to go to the left. Now, when we go to the left, you know what we do. So, minimum will be as is. So, let me write here minimum will be 8, whatever was flowing earlier, and max will be 10. That means this 9 should be in the range of from 8 to 10. Okay, should be in the range from 8 to 10. Okay, now when we go to the right, again, when we go to the right, now what is going to be? So 10 will be minimum and maximum was whatever it was, right? Maximum was plus infinity, which is again, it is boundless. So here 12 should be greater than 10 and should be lesser than this uh, plus infinity. Okay. So each and every node is following the property of BST. Okay. So so we can say this is a valid BST. Now quickly let's dry run. So here 10, right? We are going to pass minus infinity plus infinity here. We go to the right. We are going to pass minus infinity and 10, right? This is following the property. This is greater than minimum. This is less than maximum. Okay. Now we are going to go to the right. When we go to the right, we pass 10 as the node value in the minimum and plus infinity will be as is. Is this following the property of BST? 20 is greater than 10 and it is lesser than plus infinity. Yes, it is following. Now we're going to go to the left. Okay. So when we go to the left, what we're going to do, we'll keep 10 minimum, right? 10 minimum and 20 as a maximum. So if you see, this is violating the property of BST because 9, okay, because 9 is not greater than 10. 9 is not greater than 10, right? Right. 9 should have been greater than 10. All the values on the right subtree should be greater than the parent node. That's what it says, right? So, okay. So this is not greater than the node value, right? This is not greater than min. And 9 is less than max. This is a condition, right? So this is violating the property. So 9 is not greater than min. It is less than. So, and hence we can say this is not a BST. Okay. So I hope you got the intuition. Now let's quickly go and code. Before going to the code, I'll just request to please subscribe to the channel, like the video. Okay. So let's quickly write the function BST util. Okay. So first I'll show the Java code followed by C++. Okay. So root, and then we're going to pass integer dot min value, okay, in the min variable, and integer dot max value as a max variable. Okay, now so BST, let's call it BST utils. So boolean BST util, right? Node root int min, then int max. Okay, now we're going to check here if root equal to null, then we are going to return false. Sorry, return true. Return true. This will be true because null is again also it's a property of BST. Okay, this will be the base condition. Now what we're going to do is root. If root dot data is greater than minimum, right? Or root dot data, sorry, if root dot data is less than minimum, right? And root dot data or root dot data is greater than maximum. That means this is violating the property of BST. So we are going to return false here. Okay. Okay. Otherwise, what are we going to do? Int L, we're going to pass BST util root dot left. So when we go to the left, we're going to keep the minimum as is, but the maximum needs to be root dot data. I've already explained this. Similarly, we'll go to the right, 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 and here we are going to pass minimum as root dot data. Okay, that is the whatever the right elements, right? What are the right elements? They should be at least greater than equal to min, which is root dot data, the parent node. And here the max will be changed, unchanged. It will be as is, right? And finally, both L and R, they should be true, right? In order to call them as BST. Okay. Both should adhere to the property of BST. Let's quickly compile this. Oh, there's one error here. We also have to return. right? And what is wrong here? BST util. Oh, my bad. This should be Boolean, right? Boolean we are returning. And both should return true. Okay. And that's when we can say that it's adhering to the property of BST. Again, some compiler error. What is it? Okay. It needs to be integer. My bad. Okay, the test is a pass. Thanks for watching. Please subscribe to the channel, like the video. Let's quickly see the C++ code. Okay, so here's the C++ code. Here we have int min and int max as an inbuilt constants for minimum and maximum integers. We're passing as min and max. Here the base condition, if root is null, then it is BST definitely. And here if it is violating this condition, right? Or this condition is meeting, that means we can say that it is violating the property of BST. Okay, and here we are having the status of left subtree status and right subtree status, and here both needs to be true. Okay, in order to call it as a BST. Okay, so thanks for watching. I'll attach the code in the description section. Okay, please subscribe to the channel, like the video. I wish you a very happy, healthy, wealthy, and a great day. Thank you so much.